Okay, so good afternoon and welcome to lecture number 26. Today we'll be studying syntactic object recognition, and particularly in this lecture we'll be studying the principle of how syntactic object recognition works, and then at the end, if time permits, we will study about recognition as a graph matching in syntactic pattern recognition. Okay, so if you look at the syllabus of the fourth chapter, okay, so this part we have covered, and this is left. So there is syntactic object recognition and syntactic this one recognition as a graph matching. So possibly we'll cover this entire part. If it is not possible to cover within time, then remaining part will continue in our tomorrow's lecture. Okay, so just to revise, I'll take quickly the difference between the statistical object recognition or pattern recognition and syntactic pattern recognition, so on. So the first difference is that in statistical pattern recognition, first we extract the features. These features are in the form of numbers, or numerical features are there. Whereas here in syntactic pattern recognition, okay, we extract the feature by using symbols. Okay, so symbols are used for representing the structure of that object. So here, basic primitive, okay, basic is here feature, that is numerical feature, whereas okay, here we are extracting the primitives, or that is called as the symbols. Okay, and from this feature, okay, in statistical pattern recognition or object recognition, feature vector is formed, and the dimension of the feature vector depends upon the number of features we have extracted. Means if we extract the features, 10 features, then that feature vector dimension will be 1 by 10. Whereas here also the language depends upon the number of primitives which are used for representing that object, structure of that object. So we are, okay, here we are basically representing the structure of the object, and here we are representing the numerical features of that one. Okay. Now, second difference is that when we can use this statistical pattern recognition or object recognition, and when we can use the syntactic. Okay. So if the we have a strong statistical features in the application domain, then one should use a statistical object recognition. Otherwise, if it is not strong, statistical features are not strong, then classification accuracy or recognition accuracy will be less in that case. Or a problem is complex, which cannot be represented with the help of simple numerical features, then in that case you can go ahead with syntactic object recognition or structural object recognition, and okay, in that you can use this primitives and so on. So should be used whenever feature description is not able to represent the complexity of the object, or when the objects are represented as a hierarchical structure consisting of simpler parts. Okay, so this simpler part is nothing but this one, your primitives or symbols, okay, which will be used for representing the structure of that object. I hope that you have understood the meaning of this one, primitive or symbol. So here basically it is numerical feature, whereas it is here it is a symbol or primitive, right? So this example is like as a graphical representation of the object and so on. Then the elementary properties of the statistically described objects are called as the features, whereas the elementary properties of the syntactically described objects are called as the primitives, okay, or symbols or primitives. For example, border primitives representing the part of borders with specific shape. Okay, so like for example, if I have the shape like this, okay, this greater than symbol is there, and then horizontal line is there, okay, and again this kind of symbol is there. So this symbol is considered as a one primitive, and then horizontal line is another primitive, and then this symbol we can consider that as a third primitive, right? So there will be three primitive for representing that symbol, right, or that object or that skeleton of the object and so on. So there is no requirement of obtaining the relational structure between the features. So whatever the feature vector you get, suppose for example you have extracted the 10 features, so you don't have to establish the relation between the first feature and second feature, or second feature and third feature, or third feature and first feature, and so on. So there is no need of obtaining the relational structure between the features in case of statistical approach, whereas in case of syntactic or structural approach, after each primitive has been assigned a symbol, the relation between the primitives in the object are described, particularly in graph-based technique, okay, and relational structure results from that one, okay. So that is the difference between the syntactic and statistical. Then the feature organization is by feature vector. So if you have extracted 10 features, then okay, by organizing these 10 features in a vector form, you get the feature vector of that object, whereas feature organization is done to the primitives. So primitives are arranged and observed relation, their relation also, okay. So features are organized like as a primitives and their relation in case of structural or syntactic pattern. Then here, extracting feature is an algorithmic approach. As I said yesterday, that like for example, you have used the wavelet transform for classification of the texture object. Then what we'll do, you will read the image. Then the second step of that algorithm is that decompose the image for okay up to 3 levels. So if you are decomposing the image up to 3 level, every level in the wavelet transform, you will get 4 subband, that is LL, LH, HL, and HH. Again, for second level, you'll get 4 subband. For third level, you'll get 4 subband. Then from this subband, you can extract the feature, and then these features, okay, whatever you get, you can arrange those features in a vector form that will represent the feature vector of the given object. Okay, so this is basically the algorithmic process, and here you don't need expertise in this case. But here, in the case of syntactic or structural object recognition, design of description primitives and their relation is not algorithmic, whereas this is algorithmic. And second thing is that, the last thing is that the expertise in the analysis of problem or designer experience is needed, whereas this is not needed in case of statistical patternization. Okay, I hope that you have understood the clear difference between statistical object recognition and syntactic or structural object recognition. Now we'll study in detail the syntactic object recognition. So what are the principles behind that one? So principles in the syntactic pattern recognition method is that, as I said that, okay, instead of features, you are going to extract the primitives. So the number of primitives type should be small. Okay, don't extract many features, okay, many primitives. So select the primitives such that, okay, it will be required for constructing or representing the structure of that object. And these primitives should be small in number and so on. So that is the first principle in syntactic object recognition and so on. The second principle is that the primitive chosen must be able to form an appropriate object representation, right? So like as I explained that, suppose for example, if I have the skeleton like this one, okay, and then this shape like this one, okay. So here a primitive like this one, and then horizontal line, and then this one. So these are sufficient. These 3 primitives are sufficient for representing that object. So primitive chosen must be able to form an appropriate object representation. So that is the second principle in syntactic object recognition. Then the third principle is that these primitives should be easily segmentable from the image. So whatever the image you have, okay, so and whatever your primitives you are going to select, it should be easily segmentable from that image. And when you assemble it, okay, you should get the structure of that object easily. Okay, so third principle is primitive should be easily segmentable from the image. The fourth principle is that primitives should be easily recognizable using some statistical PR methods. Okay, so if you are combining that statistical and syntactic, the primitive should be easily recognizable using some PR or statistical PR methods. And the fifth one is that primitive should corresponds with significant natural elements of the object, like okay, so triangular object or circular object or rectangular object or square object. So this kind of okay, these are the natural element, okay, natural elements of the object, and you can select this kind of primitives. So primitive should correspond with the significant natural elements of the object or image, and structure being described with the help of them, right? So these are the 5 principles which are used for selecting the primitives in syntactic object recognition or structural object recognition, right? I hope that this is clear to you. Then, what is the concept of syntactic recognition? There are 4 stages, okay, in syntactic recognition. In case of statistical, what was the concept or what was the principle in statistical pattern recognition or object recognition? There were 2 phases. One was basically training phase, and another was testing phase. So in training phase, what you do is in supervised learning approach. So your training data are separate, testing data are separate. Then these samples from training data were given to the pre-processing unit. Then pre-processing unit will basically remove all those unwanted things, and then data will be cleaned. And then after that, feature extraction was done. And once feature extraction is done, after that, third stage was feature selection. And then after feature selection, the strong features which are selected, then these features are given to the classifiers. Okay, so basically, okay, this is in case of this one testing page. But in case of training page, what you are doing, you were basically taking the samples from the training data, then cleaning the data, that is noise removal and pre-processing, then extracting the feature. From once you have extracted the feature, from those features you were creating the this one centroid of that class, that is mean feature vector from that one for each class. And then once that training is over, after that testing phase was done, and then classification was done. That was basically a principle in a case of statistical object recognition. But in case of syntactic object recognition, there are 4 phases basically. One is learning, okay, learning, that is based on the problem analysis, define the primitives and their possible relations. So this is learning stage. This first thing is that you have to extract the primitives, and second thing is that you have to okay, obtain the relation between all those primitives, and that is extract the structural features of the pattern. So this is nothing but the learning phase in case of syntactic object recognition or structural object recognition. So what is this one? Define the primitives first. Okay, so knowledge in that is very, very essential. And then second thing in the learning is that you have to develop the possible relation between all those this one primitives. Like I took the example in 3rd chapter while developing the graph. Okay, I took a simple house, and then in that house there was a roof one. We can consider roof as one primitive, then front wall as a second primitive, then okay, side wall as a third primitive, and then top of side wall also as a 4th primitive. Then okay, we can represent that one as either character or this one, and then we can develop the relation that okay, A is left to the B, B is on the top of C, C is to the right of D, or D is on the bottom of A, and so on. So like that way you can decide basically the relation. So the based on the problem analysis, you have to define the primitives and their possible relations, and that is extract the structural features of the pattern. So that is the first phase, that is learning. Second thing is that the grammar. Okay, as I said that, see, this is higher level representation or higher level recognition and so on. And you know the difference between the higher level language and lower level language, the concept which is used in the computer. So lower level language basically is this one binary language which is understood by the computer or your processor and so on. But the programming which is done in higher level language, it has a particular syntax, and then a particular set of rules are there and so on. And then you don't have to do the programming in 1 and 0. You have to do the programming like as the language which is used by the human being for communication. Similarly, since it is a higher level, this one object recognition, that is structural object recognition, is considered as the higher level object recognition. So definitely here grammar will be the important thing for along with this primitives and the relation and so on. So grammar is nothing but basically a set of rules and so on. So construct a description grammar for each class of the object using either hand analysis of syntactic descriptor or automated grammar inference. Means for each class there will be a separate grammar. Like class C1 is there, so set of grammar will be Z1 for class C1. If class C2 is there, grammar for class C2 will be Z2. Class CK is there, grammar will be ZK. So for every class, grammar will be different. So you have to develop that grammar. So construct a description grammar for each class of the object using either hand analysis of the syntactic descriptor or automated grammar inferences. That is, generate a set of rules or called as the production rules. And these rules governs the interconnection between, what is that rules? These rules are nothing but the interconnection between the said primitives. So what is the connection between the first primitive and second primitive and third primitive, third and first, and so on. So that is giving you the set of basically rules which are nothing but the interconnection between the said primitive, and thus they form the grammar for that particular class. So one thing you have to note, that is in grammar, it is the set of rule or production rule for every class. So for every class, this set of production rule is different. Means if class C1 is there, there will be set of rules of grammar Z1. If class C2 is there, there will be grammar Z2. If class CK is there, there will be grammar ZK, and like that way. So that you have to develop. Then the third step is that for each object, okay, extract its primitives first, recognize the primitives classes, and describe the relationship between them. That is, construct the description word representing an object. So we basically that is called as the language basically. Okay, so for each object, extract its primitives first. Okay, we are extracting the primitives first for every object or for every class. Recognize the primitives classes, okay, and describe the relationship between them and construct a description word. So this description word is nothing but the language of that class. So for language of every class will be different, right? So when you have, okay, so for example, in the database you have, or in supervised learning approach, you have 10 objects are there. So in standard languages for 10 object classes will be, L1 will be language for class 1, L2 will be language for class 2, L10 will be language class 10, right? Then what do you have to do? For the unknown pattern, basically you have to extract the primitives first and then recognize those primitives classes and describe the relation between them and construct the description word that will represent that language of that class. Now this language, okay, whether it is matching with the language first of class 1, okay, if no, then try to match with class 2. So like that way, and if that language of unknown object is matching with the language of known object in the database, then that unknown object is classified or recognized as this belongs to class Cn or Ck, something like that, right? So based on the result, a syntactic analysis of the description word classify an object into that class for which its grammar can generate the description word. So this description word is nothing but the language of that class. Okay, so what is the fourth step? Based on the result, a syntactic analysis or structural analysis of the description word classify an object into that class for which its grammar can generate the description word, right? So these are the four stages which represent the concept of syntactic recognition. What is that first stage? First stage is that learning. So based on the problem analysis, define the primitives and their possible relations. That is, you are extracting the structural feature of the pattern in the first stage. Then second one is that you have to construct the setup rules, that is production rule, and that setup production rule is nothing but the grammar of that class. So these rules govern the instruct connection between the set primitives, thus they form the grammar of that class. So for every class there will be separate grammar, right? Then third step is that recognition. So for each object, extract its primitives first, recognize the primitives classes and describe the relationship between them and construct the description word representing an object, right? Then fourth step is that based on the result, the syntactic analysis or structural analysis of description word classify an object into that class for which its grammar can generate the description word, that is matching. You're fine, okay, matching with the standard one which is available, right? So now we'll see the what is by exactly the grammar and language. So grammar and language so is nothing but the set of patterns from a particular class corresponding to a set of word. Okay, this set of word is called as the formal language. So whatever the word you get, like from the interconnection of these primitives, or by arranging those primitives, you will get the set of word, because every primitive is represented either with symbol or character and so on, right? Suppose for example we took the example of this simple structure like this, okay, and then this one. Okay, so this symbol, okay, it can be represented as a horizontal line, can be represented as B, and then this symbol can be represented as C. So what we have A, B, B, and C. So that is nothing but the language of that class, right? So this set of word is called the formal language and is described by a grammar, right? So grammar is a mathematical model of generator of syntactically correct words, right? So grammar is a mathematical model of a generator of syntactically correct words, right? Now, see the definition of grammar, okay? Okay, so grammar may be defined as a four tuple, okay? So which are the four tuple? So grammar consists of VN, VT, P, and S, where what is VN, what is VT, and what is P, and then what is S. So it is a four tuple. Grammar is defined as a four tuple. So out of that one, first one is VN, second one is VT, third one is P, and fourth one is S. So this VN is basically the finite set of non-terminal symbols or variables that represent the intermediate constructions. Okay, so Vn is non-terminal symbols, whereas Vt is the terminal symbols. So the finite set of a terminal symbols or alphabet or constant, that is structural primitives that represent the final substitution phase of the production of sentences, that is patterns or objects. See, like for example, okay, I'll just try whether I'm able to draw this one. Okay. Oh, sorry, this one. Suppose, for example, if I have a pattern like this, okay. Okay, so this is suppose, for example, this is the skeleton of the object. So what I'll do here basically, okay, I'll define this as one primitive, okay, and which I'll represent that as a. Then this symbol I'll represent it as a b, right? Okay, now this b is repeated, suppose for example 3 times here, and then this symbol which I'm considering as a primitive for representing the structure, I'll represent it as a c. So this, okay, this is a, right? And so this is basically a, right? Oh, sorry. Okay. So this is particularly A, and then this part is B. Okay, this is B is repeated. So for example, 3 times, and this symbol, okay, which we are using as a primitive, okay, as a C. So this is A, B, 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 and then C. So the language of this class will be what? A, B, 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 and C, right? So this A, B, and C are nothing but the terminal symbols. Okay. So to obtain, so this VT is the finite set of terminal symbols or alphabets or constant, that is the structural primitives that represent the final substitution phase of the production of sentences, that is patterns or object. But while obtaining this basically language of this class, okay, we have to substitute with the help of production rules, and for that we need a set of non-terminal symbols like capital A, capital B, and so on, or variables that represents the intermediate construction. So intermediate constructions will be represented by non-terminal symbols, whereas terminal symbols are nothing but whatever the primitives you are using. So that set of primitives is nothing but the terminal symbols or finite set of terminal symbols or alphabet or constant, that is structural primitives that represent the final substitution phase of the production of sentences. Whereas S is nothing but the grammar axiom or the start symbol. So basically S is nothing but the start symbol where you have to start, and then for obtaining the grammar you have to have the set of rules basically. For obtaining basically the language of that class, you should have the set of rules, so production rules. So P is the finite set of production rules defining how symbols can be combined to form the sentence, and this sentence is nothing but the language. So this grammar in the syntactic object recognition consists of 4 tuple, okay, is defined as a 4 tuple, where first one is non-terminal symbols, a set of non-terminal symbols. Second one is nothing but the terminal symbols, and then third one is basically a production rule, and S is nothing but the start point where to start. Okay, so these things are nothing but the grammars basically, and then with the help of this grammar we will obtain the language of that class. So as I said that suppose this is the symbol primitive, and I'm representing this primitive as a, this as a B, then this as a B, and this as a B. So and then this one as a C. So language of this class will be A, B, 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 and C, right? So that will be the language, and then see the language is nothing but the set of all words that can be generated by grammar Z is called as the language of that class. So what was the language of this class? A, B, 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 and C. So this set of word which we have generated, that will represent the language of this class. So that's the set of all words that can be generated by grammar Z is called as the language L of Z, right, of that class. So for every class, language will be different, right? So in the present context, language corresponds to a class, okay, and a grammar that generate the same language are called as the equivalent. Like for example, we have 10 class problems. So we have developed the language of first class. So we'll consider as a L1 is the language of first class, then L2 is the language of second class, L10 is the language of 10th class. Now, when unknown patterns comes, okay, with the help of set of production rules, okay, whether you are able to, with the help of set of production rules of class 1, are you able to get the language of first class? If yes, then that, okay, unknown object set to, okay, or belongs to class 1. Otherwise, if it is not forming the language of first class, then you have to use the set of production rules or grammar of second class and see whether you are getting the language of second class. If not, then this does not belong to class 2, and so you have to repeat up to number of classes, and if it is matching, then you can say that unknown pattern belongs to that class. Or if the language of that unknown pattern and language of this known class is matching, then unknown pattern belongs to this class. So in the present context, language corresponds to a class. So grammar that generate the same language are called as the equivalent class or equivalent object. So thus, in a syntactic object recognition or pattern recognition gives a set of grammars, and each set of grammar corresponds to a unique class. So for every class, the set of grammar is unique, right? And this is decided by the expert, okay, or user in that domain. So a sequence of primitives we parse the sequence using each grammar to determine whether the sequence is valid pattern of the corresponding class or not. Now, in general, if you consider the two class problem in syntactic object recognition or structural object recognition, like for example, there is a class C0 and class C1 is there. Okay, let us consider class C0 is there and class C1 is there. So these are the two classes represented as a strings of primitive. So strings of primitive is nothing but your language of class C0 and class C1. So suppose there are two grammars. So G0 correspond to C0 and Z1 correspond to C1. So Z0 is a grammar of class C0, Z1 is a grammar of class C1, okay, and then production rules are such that, now what is the grammar? Grammar is nothing basically, it is a four tuple which consists of terminal symbols, non-terminal symbols, set of grammar production rules P and start point and so on. So production rules are such that Z0 allows for the generation of sentences corresponds to the object of class C0 only. So with the help of this set of grammar of Z0, it will allow to generate the language of class C0, whereas the set of rules which are there in G1, it will allow to generate the language of class C1. So production rules are such that C0 allows the generation of sentences which corresponds to the object of only class C0, while Z1 allows the generation of sentences corresponding to the object of class only class C1, right? So the language L of Z0 generated by Z0 is the class C0, and similarly the language L of Z1 is same as C1, right? So this language corresponds to which is generated by Z0 is corresponds to class C0, whereas language which is generated with the help of grammar Z1 corresponds to language of class C1, right? Now see that once Z0 and Z1, that is grammar of class C0 and this is grammar of class C1 have been established, okay, then in general a class of object may be defined by more than one grammar, and when there are more classes, the syntactic classification approach is same, except more grammar involves in the process. Now suppose for example how syntactic object recognition works. So given a sequence of primitives representing an unknown pattern, suppose for example you have a sequence of primitives of unknown pattern. Now if this sequence or if this language is the sentence belongs to L of Z0 is similar to the language of class C0, if yes, okay, now you can generate the sequence of this language of this unknown pattern by application of grammar Z0. So if this language and if this language L of Z0 is same, then we can say that unknown pattern belongs to class C0. If not, then what you have to do? You have to apply the sequence of grammar or basically set of rules of grammar G1 to the unknown pattern and see what kind of language you are getting. If that language is matching with the L of Z1, then that object belongs to class C1. Otherwise, okay, you have to say that this object, unknown object, does not belong to C0 or C1. It is something else. So like that way, this syntactic object recognition works, and the remaining part of that one, that is gram patching, and then length and distance, and so on, syntactic classifier. So that we will study in our next lecture, that is in tomorrow's lecture. So today we'll stop here. Thank you very much.